Assalamu alaikum. Today we're going to start our new chapter, chapter number 11, which is geometrical construction. Okay, which, from page number 186. Okay, first of all, this chapter requires you to have a basic concept about lines and stuff like this and that. We did in the chapter number 10. Okay, so if you're not clear on chapter number 10, go back and read the basics again. Otherwise, this is going to be pretty simple, pretty easy. This chapter is very simple and easy. Unlike previous chapters, we had to use algebra in it, and we had to use linear equations and find the value of x and missing numbers and this and that. This chapter is very simple. You just have to draw a set of angles. Specific angles will be given to you, and you just have to learn how to draw them. Methods, you have to memorize those methods. You have to practice those methods, and that's it. There's no finding x in these questions or this chapter. You can say it's pretty simple. It starts off by reminding us what a ruler is, in case you don't know, and what a protractor is, and a set square. So if you have something like this, good. If you don't have it, go buy it, because you will need it in this chapter. Okay, it's called a ruler, or some people call it a scale. We use it to measure length. Okay, then we have a protractor. Some people call it semicircle, some call it D, but the actual name for this tool is protractor. Okay, let me show you. Where is it? Yeah, I have two here. One of this and one is this one. Yeah, this one is much more clear, so we're going to use this. Okay, first of all, protractor, we use this to measure angles, and we've already used it before in the previous chapter, but we're going to draw a lot of angles in this chapter, so you need this. If you don't have it, go buy yourself a protractor. Protractor. It's not a protector. It has an R in it here. Okay. One more thing about a protractor. We're just going to remind you of a few things. This thing here, we have a center. Okay, center of this protractor. This is baseline of the protractor. Okay, this is the outer scale, the one that is on the outside, and this is the inner scale, the one is on the inside. Okay, we're going to learn how to use it. We're going to measure angles with this. Again, I'm going to show you how to use it, but for now, just remember that this is a protractor. Other than that, we have these tools. They're called set squares. The basic and the most simple purpose of them is to make 90-degree angles. You have an L shape here. That is a 90-degree angle, so you can use this to make 90-degree angles instead of using protractor, because protractors takes time to use, and this is very simple. You just have to go like this and that. It's pretty simple. You can make 90-degree angles with this one. You won't really have to use this much this tool in this chapter, so you can forget about square sets. Other than that, we have compass. Okay, what is a compass? Basically this tool that we have here. This is a compass. It has pair of arms, you can say, and movable arm. It has two pair of movable. It has a pair of movable arms. One this one and one this one. One has a pointy thing, and the other one is for drawing. Okay. One has a pointed end, and the other one has a drawing end. They're used for drawing circles and arc of a circle. Now the question is, what is an arc of a circle? We know what a circle is. I can just place it here and I can twist it around. That's a circle, right? What is an arc? Arc basically means a portion of a curved boundary of a circle. Arc is what? Arc is a portion of a curved boundary of a circle. For example, let's say I have this rough page here. I make this line. This is an arc. It's an incomplete kind of circle, right? This incomplete curved line, this is an arc. This is an arc. This is an arc. I can go here, cut this arc. Now I have two arcs cutting each other, intersecting at this point. Okay, so these two are different arcs intersecting at this point. That's what arc is. And we use a compass to draw arcs and mark off. Okay, one more purpose for a compass is to mark off lengths. What does that mean? For example, I want to draw a line of, let's say, 4 centimeter. So I'm going to place my compass here on 0 and 4. okay, here like this, the pointed end on 0 and the drawing one on 4. This is 4 centimeter. Now this is going to measure 4 centimeter. One thing is that I can just simply draw a line here. First of all, line goes indefinitely in both directions. I'm going to place it in one end here and mark off the length. This shows how much it's going to be for length. Okay, I need to make sure that I think it was here. Yeah, this point. I'm gonna show you like this. Yeah, this is 4 centimeter. I made a line and marked off 4 centimeter on it. Other than that, you can use a compass to copy paste lines. For example, this line, I want to copy paste it on top of this one. So what am I going to do? I'm going to place one end, the pointed end here, and the drawing end here. I'm going to adjust it until it is exactly of this length. Then I'm going to come here and anywhere, like for example, I want to paste it here. So I'm going to make a line here and I can just go back and draw it back. You need to make sure that the pointed end is clear. Okay, for example, here I can feel the groove, I can feel the hole here that I've made by using this pointed end, right? So I'm gonna go ahead and mark it. Then I can connect the arc in a proper good manner. Okay, the good accuracy is important. Again, so I copy pasted the line. I didn't knew its length, but I was able to copy paste it using this compass tool. This is very basic kind of thing. You should have done this before as well. Okay, I'm not sure if you have or not, but this is what you use a compass for. Other than that, we can draw angles using a compass, and that's what we're going to do in this chapter. We're going to draw angles using this. Instead of using a protractor, we're going to use compass to draw angles. Other than that, there's nothing more. Oh yeah, there's one thing very important that we forgot to mention. A pair of compass is different from a compass which is used to tell direction. This type of thing, it's also called a compass, which we use to tell the direction, north, east, south, west. That compass is used for finding the directions, but this compass, you can't find the directions from this one. Okay, we're going to use it to measure and make angles and stuff like this and that. Don't use this one to draw angles. Okay, you're going to be wrong then. Make sure you don't confuse these two things. They're very similar in names, at least. Otherwise, here we don't have, literally this is just very simple. Drawing a circle or an arc of a circle. Take this, adjust the arms and to the length. For example, first of all, let's learn how to draw a circle. The question will tell you that the radius is, let's say the radius is 9 centimeters. Okay, let's say the radius is 9 centimeters. First of all, what is the radius in the first place? Radius is the distance from the center of a circle to the end, to any point on its edge or boundary. Means if this is the center of a circle, this is a circle, this is its center, from the center to its boundary, to its edge, to its circumference, sorry, anywhere, like here as well, doesn't matter. This distance is going to be known as radius, and radius is always constant for a given circle. For example, if I tell you that it's a circle of 9 centimeter radius, the radius is going to be constant on each and every turn, like here, everywhere the radius is going to be the same. The radius is going to be same from the center to this edge, to this point on the edge, and from the center to this point on the boundary. Is always going to be the same. The radius doesn't changes for a given circle. Okay, other than that, we have diameter. Diameter is always twice the radius. Whatever the radius is, multiplied by 2 and you will get the diameter. Because diameter is basically a line that passes through the center of the circle and cuts it into two equal halves. That's what a diameter is, okay? From one point on the edge, crossing from the center, and then to the other point on the edge. That's what a diameter is. Why radius and diameter are so important? Basically, just like in squares, we use length, right? We use side. In rectangle, we use side. In what do we have, like, yeah, in triangle we also use length and base and height. Basically, in circle we have radius. We use radius to find the area of a circle. We use radius to find the circumference of a circle. In other words, perimeter. Circumference is basically the perimeter of a circle, right? So radius is really important to get the information about a circle. And if you want to draw a circle, first of all, let's say the question was what? Question was that the radius is 9 centimeter. So I'm going to take my ruler, I'm going to take my scale, and I'm going to take my compass as well. Place the pointed end on 0 once again and go all the way to 9. All the way to 9, right? This is now on 9. So this is 9 centimeter. The compass was adjusted to 9 centimeter. Now I have to place it in the center here and draw a complete circle. This circle, which is very big, actually, wait a second. We just draw this circle here. This circle, basically, it's kind of incomplete, but this circle is a 9 centimeter radius, has a 9 centimeter radius. The point of me showing you this was basically that there isn't much more anything complicated here. You just have to adjust the compass to the radius that is given to you and draw a complete circle with it, okay? One more thing that you need to remember is how to use a compass while you're doing construction, okay? The most important thing in this chapter, and the one thing that you really need to be careful about, is the adjustment of the compass, okay? Sometimes you will be allowed to adjust it, to extend it, or you can say shorten it down, but in some cases it will be very, very clear to you that you have to make sure that you don't mess with the adjustment. In simple words, right now, let's say this is how much? Let's say this is 3 centimeter, right? If the compass is 3 centimeter, it needs to stay that way. 3 centimeter radius, basically, right? So if a compass has a 3 centimeter radius, it needs to stay that way in some calculations that we will do. I'll show that to you when we're doing that in this chapter, but that's exactly what one thing that you need to remember about it is basically that. Other than that, you can use the compass to mark off length, make an arc of a circle, just like I showed you. For example, this is just how you make an arc using a compass, nothing more than that. Okay, I've already showed you how to mark off length, and quite frankly, there isn't any much more complications here. This is very simple. Use a ruler and place your compass on it, just make an arc and then draw the line. This is basically it. You can read the steps again, and the things that are really need to be careful of, I've already highlighted them. Without adjusting the arms of the compass, okay, this is where it gets important. When you're marking off length, for example, I said draw 5 centimeter line, right? Or you can say mark off 5 centimeter. This is 5 centimeter, correct? I am not going to mess with this adjustment. I'm going to carry it to the line properly, making sure that it's not messed with, and then I will make the arc like this. In some cases you will be allowed to move the compass like this, or you can extend it further, but in some cases you will have to be really, really careful of this thing. Useful tips in geometry: use a sharp pencil, okay? Make sure your pencil is sharp. geometry needs to be very precise. Okay, geometry needs to be very precise. If your calculations are far off, or you can say you're supposed to make 90 degrees and you made 85 degrees, that's wrong. You need to be very proper and careful while making geometry, because geometry is basically what helps us properly make designs in constructions and in architectural plans and whatever plans you make to make all the human made designs we have. In machines we have these geometrical designs, in computer we have the proper components, right? Fitting each piece in its proper place, making sure that there is no gap between them. They all need specific and proper calculations, okay? And that all involves geometry. So you need to be really careful about your calculations and constructions in geometry. Okay, the intersection. Okay, one more thing is that when making an intersection with a line or an arc, ensure that the angle of intersection does not differ greatly from 90. Look, we have approximately 90-degree angle between these two lines, this arc. Here we don't have a proper 90-degree angle. In geometry, here you have to be really careful about making sure that the arcs are properly made and there's a 90-degree angle between the two arcs properly, or approximately. You don't have to be that perfect, but shouldn't greatly differ from 90. Other than that, you need to ensure accuracy. For example, this is the point of intersection. Look, in the middle of these two arcs we have the point of intersection. The line should pass through that point, not away from that point. Okay, you need to make sure to ensure accuracy as much as you can, and that way your geometrical constructions will look more beautiful and accurate. All the constructions lines must be clearly shown. Do not erase the construction lines that have been drawn. Okay, once you do all the construction, for example, like when you're making a square or when you're making a triangle or rectangle, you will have to make extra things that are not the part of the triangle, square. For example, these arcs are not the part of the shape itself, but you have to make sure you clearly show them for the teacher, for you to know what happened, okay, and how you made it. This is basically it in this first exercise 11.1. There's nothing more than that. Very basic and very simple level stuff. Okay, we're gonna go towards now something that's important, really important. Okay, this is basics of construction. We're going to talk about perpendicular bisectors and angle bisectors. We're going to start with understanding what a bisector is in the first place. A bisector is a line, ray, or a segment, means line segment, that cuts something or something. What something am I talking about? I'm talking about another line, I'm talking about another angle, I'm talking about another ray or another segment. That's something, okay? When the ray, line, or segment cuts something exactly in half, dividing it into two equal parts, that is a bisector. For example, I have this line, right? I make another line that cuts it into two equal parts. This part is now equal to this part, and this line is cutting them into two equal parts, and that means this line here is a bisector, okay? Because it's cutting them into two equal parts. I have an angle here, whatever this angle is. I make a line that cuts it into two equal parts. Then this line is a bisector, okay? That's basically what a bisector is. It cuts it into two equal parts. The two main types of bisector is perpendicular bisector and angle bisector. What is a perpendicular bisector? A very simple definition for a perpendicular bisector is that it's going to bisect a line perpendicularly, okay? A perpendicular bisector is going to perpendicularly bisect a line, and an angle bisector is going to bisect an angle. Simple. When you're bisecting an angle, that's an angle bisector. When you're bisecting a line with a perpendicular, that's a perpendicular bisector. We're going to learn how to construct a perpendicular line. Okay, first of all, we're going to learn how to make perpendicular lines first. What is perpendicular? We've already done this in chapter number 10. Perpendicular means 90-degree angle, okay? perpendicular lines have a 90-degree angle between them. So how am I going to construct a perpendicular line? I'm going to do this with you guys step by step so that you can properly see what's going on. Okay, first of all, construction of a perpendicular line to a given line from a point that is lying on it. Let me make it very simple and clear from the start. Wait a second. First of all, a scale. This is line segment AB. This is line segment AB. I want to make a perpendicular line. I'm not talking about a perpendicular bisector. I am talking about a perpendicular line. How am I supposed to make a perpendicular line on AB? Number one, I can use this. I can use this to make a 90-degree angle, and that will make a perpendicular line. Other than that, I can also use this tool to make a perpendicular line. For example, like this, I can just draw here. It'll be a perpendicular line. I can also use a compass. Wait a second. Yeah, I can also use a compass. And in this chapter, we're going to learn how to use a compass to make perpendicular lines. First, okay. Now, first of all, draw AB and mark point N on it. Let's say this is going to be my point N. It doesn't have to be the center because we're not talking about perpendicular bisector. We're talking about just a perpendicular line, okay? Then what next? With N as the center, with a suitable radius, draw an arc to intersect AB at LM end. Look, when it says a suitable radius, what does that mean? That means a radius of your choice. Okay, for example, I'm going to open it this much. I don't know what that length is, but it doesn't really matter. That's not important right now. Okay, so you're just going to open it as much as you want. Not too much, because then the circle will be too big, and that's not what you want. You want your circles or your arcs to be small, okay? In most of the cases. So I'm going to make sure I have firmly placed this pointed end on N so that it won't move from N, okay? Make sure that it won't move from N. It's not going to move away from N. And then I'm going to gently make an arc, a semicircle here. That means from point N, it needs to intersect with line A and line AB on two different points, okay? It needs to intersect line AB in two different points, this point and this point. Okay, I'm going to call this point of intersection what? I'm going to call it L. And I'm going to call this point of intersection M. The only thing that you need to learn here is the suitable radius. Basically, you will understand why I had to make a small circle when we continue with this construction, okay? Sooner and later you will understand why I couldn't use a big circle or big arc to construct this. For now, just take it that you need to make a smaller arc. With point L, with L as your center and radius of more than ln, draw an arc above AB. Okay, more than ln means more than the radius we had before. Okay, so what are we going to do? The question is basically telling us to, okay, now it says that with L as the center and a radius of more than ln, draw an arc above AB. Okay, with L as the center, so that means I'm gonna put my pointed end on L. Make sure that it's fixed there. Okay, it's not going to move around as I'm doing my construction. And one more thing that you need to be, well, it says here that the radius of more than ln. What it means is that the radius that we had before, this one, right? Now your radius needs to be more than that. It can be this much, it can be this much, but it's better to just be a little bit more. It's not too much, not too less, not too much. Okay, for example, like right now, my radius is definitely much more than ln. okay, but it's not too much that I will waste my page. Okay, so I made an arc here, making sure that it's on the L. I made an arc above AB. Follow the instruction with M as the center now of the same radius. Which radius? I'm not gonna readjust the compass. Okay, you need to make sure about this is the most important step while making these perpendicular lines. Once you make an arc here of this length, whatever it is, you're not going to change that as you place it on M and make another arc. So I'm gonna make sure I place it on M firmly. Now I'm going to make another arc. Okay, this was my second arc. The length, or you can say the radius I had for the first arc and the second one from L and M both needs to be the same. Okay, this is really important. First time while making this one, you need to keep the same radius while you're cutting an arc here and you're cutting an arc here. They need to be the same, and then after that, when you're making more arcs from on point L and point M, okay, they both need to be the same. Okay, now that you have your intersection here, you can mark it off as well. Basically here I have my intersection. Then what do you need to do? You need to name this intersection as point P, basically, you can say. And then you're going to take your scale and just draw a straight line from N to P. This is joining P with N, and this means you have made your perpendicular line. That's how you make a perpendicular line. Again, this line is perpendicular. First of all, I'm going to give it to you in a very simple way. This line is AB. This line is PN. PN is perpendicular to AB, but PN is not bisecting AB. Okay, this length of AB, this part of AB is not equal to this part. Okay, that's why PN is a perpendicular line, but PN is not a perpendicular bisector. One thing clear. Second thing, I'm going to give it to you in very simple way how to draw a perpendicular line. First, take a suitable length, for example this much. Okay, take a small suitable radius. Draw a semicircle, any point. You can draw it here, from here as well. Make a semicircle. Okay, you're going to take the intersection points, like this is my center, right? From the center and this one here, I have intersected the line AB here. I'm going to call this point, let's say D, and I'm going to call this point E. So then DE as my center, I'm going to take a radius that is longer than this. Look back, I had this much radius. Now my radius is going to be a bit more than that. Okay, it doesn't have to be too much more, it can be just a bit more. Then, oh sorry, I made the arc from a wrong place. Let me just remove that. Yeah, the arc needs to be from the intersection points of intersections, from E and from D, making sure that their radius or their length, you can say, you're not going to mess with the compass while you're making these two arcs, and the radius for these two arcs needs to be more than the first radius that you had. And the rest is just simple. You just need to make a point here and join the two lines together. Simple as that. You will make your perpendicular line. I didn't do it that properly, I was just hasty, but you need to do it properly. Okay, you can practice this again and again, making sure you know how to draw perpendicular lines. Okay, other than that, once you learn how to make perpendicular lines, you can also make perpendicular lines on, basically what happens in worked example 2 is that let me just show it to you here. I take a parallel line, I make a line. This line is, let's say, XY. Now I'm going to call this line XY. Any point on this line, I'm going to take it like, for example, this point. Okay, I'm going to mark it, I'm going to name it as well. This is point B, this point is B. Okay, this is my center. I'm going to open a suitable length. Okay, I'm going to make a semicircle here. Oh, it's okay, need to make sure that the radius remains the same. Now what happens if you mess with the radius? Your constructions will be wrong. So you need to make sure you understand when to change the radius of this compass and when to not change it. Right now, as I'm making the semicircle, I'm going to need to be careful that I don't change it. After that, I can change it. Okay, first of all, the semicircle is complete. I have made my intersections clear. Okay. Yeah. This point of intersection, I'm going to call it, let's say, I. I'm going to call this one point of intersection P. It's my choice, I can name them whatever I want. This is point of intersection P, this is I. Now what am I going to do? I need to take the radius, any radius, like literally just, it can be a little bit more, or it can be clearly a bit more, or it can be too much, but don't be too much or too less. Okay, now from point P as my center, I can make an arc here. How much should the arc be? It doesn't really matter as long as it's clear enough to you. And from here I'll make another arc, and I'm going to do the same to the bottom as well. I'm arc in the bottom here and arc here as well. Now this point and this point of intersection, let's call this one A, let's call this one C. I'm going to join all of them together. The line AC should pass through point B. My one is still bad because I didn't do it properly, but yeah, this is going to be perpendicular. You can confirm that by using a protector. Let me use a protector to see how much is it. It's about 90. Yeah, it's about, wait a second. Yeah, the line is 90. All the pieces are going to be 90. Okay, this one is also 90, this one is also going on, all the other parts are also going to be 90. Okay, so if the question is asking you to make a perpendicular line on the line AB or on the given line, then you're going to do this. If the question is asking you to make the line that make a perpendicular line that goes through the given line, then you're going to do this. Basically that's it. Okay, there's nothing more complicated than this. That's just how you make a perpendicular line. You learned how to make a perpendicular line. Now we're going to talk about how to make a perpendicular bisector. Okay, this is also very easy. For example, I have line, let me just make line. You need to be careful of, okay, you can just read this out as well first. Let's just first read it out and then I'll explain it to you how to draw it. Perpendicular bisector. M is the midpoint of the line segment AB as the line XY passes through M. XY is said to bisect AB. XY divides AB into two equal parts. Right now this isn't really telling us how to construct it. This is just telling us what a perpendicular bisector is. It's telling us that point M is the midpoint. That means this side of line AB and this side, this part of line AB, they're both equal to one another. Okay, these two equal signs that you're seeing here, two lines that you're seeing here, this shows that both of these sides are equal to one another. Okay, and XY is bisecting them. Okay, XY, the line XY, it's bisecting them, means it's cutting AB into two equal parts, this part and this part, and this is going to be known as the perpendicular bisector, as it is perpendicular anyways. How are we going to construct a perpendicular bisector? Okay, question tells you to bisect um, let's say 8. Should I 8? Okay, let's say 8 centimeters. This is 8 centimeters, correct? Question is telling you to bisect 8 centimeters. Now obviously if you cut 8 into 2 equal halves, it's 4 centimeters. So you can also use your ruler to basically say that this is the center and do it like that. But no, that's not what we're going to do. In this chapter, we need to learn how to use a compass. Don't ask me why, we just have to do it, okay? We're going to use a compass to cut this line into 2 equal parts, okay? This is 8 centimeters, half of it is 4, so each part should be 4 centimeters. I'm just going to write 8 centimeters here, okay? AB is 8 centimeters. What am I going to do? First of all, I'm going to take A as my center. I'm going to make sure I open this. I'm going to open my compass more than the approximate center. For example, I don't know where the center is. I don't know where the midpoint is right now, okay? I don't know where 4 centimeter is, but I'm going to make sure I open it much more than that. For example, this much. I know that this is more than the middle, right? Common sense. You can just look at it and see that this is much more than the middle. So I'm just going to open it more than the middle, and I'm going to make what? I'm going to make a line on the top, and I'm going to make a line on the bottom. Okay, an arc basically, not a line. From point A, making sure that my pointed end is firmly on A. Okay, it needs to be exactly on A. And then I should make 2 arcs, one on the top and one on the bottom. Then do the same. Do not mess with the adjustment of the compass. Right now, as I have made this A, the arc that I have made from point A, I'm going to keep the same adjustment for point B, okay? As I'm going to make an arc from point B. See, my compass is on point B. I didn't mess with the adjustment, and I'm gonna cut that's it. I made 2 arcs, one on the top, one on the bottom, from both A and B with the same radius, okay? With the same radius means I'm not going to change the adjustment of the compass in this calculation, in this construction, okay? This point of intersection and this point of intersection, if I join them together, this is basically how you make a perpendicular bisector. You can say, yeah, that should do it. This is our perpendicular bisector. Let's name this point M, and let's name this point N. So the line MN is basically bisecting line AB. We can prove that using a ruler. I hope it's 4. Oh yeah, it is 4. Good. It's 4 centimeters. The line was 8 centimeters. This part is 4, and this part is also 4 centimeter. That means I have successfully bisected 8 centimeters into 2 equal parts using this simple method. All you had to do was to make 4 arcs, all of the same radius, okay? From point A, you need to make sure you open the radius more than the center, okay? More than the midpoint, this much more. Look, basically it can be this much, it can be this much, it can be this much, but as long as it's more than the middle, okay? Approximately should be more than the middle. I could have made it like this as well, and then from the same other point the same, okay? That would have been like this. Doesn't matter, it will always pass through the intersection anyways, okay? The point is, first of all, you need to make sure that the radius of this compass we open should be more than the midpoint, okay? A little more or a bit more, it doesn't matter, as long as it's more. Then we need to keep it same throughout our construction, okay? From point A, I'm going to make 2 arcs, one on the top, one on the bottom. From point B, I'm going to make 2 arcs from top and the bottom, and it just needs to be the same, okay? The radius needs to be the same. And otherwise, you can read the construction steps as well. it does the same thing. You'll know how to construct a perpendicular bisector. Okay, you can do the practice like that. Oh, I did the practice. Yeah, good job, me. After that, investigation. Investigation, you can read it. Okay, I'm gonna read it as well. In this investigation, we shall conduct and deduce the properties of the perpendicular bisector in the line segment. A suitable interactive geometry software may be used. Well, we don't have a computer here, so we're just going to use a page. Draw a line segment. Okay, I drew a line segment AB. Construct the perpendicular bisector. Okay, I have made a perpendicular bisector. Join A to any point C on the perpendicular bisector, then join B to C. Okay, the question is, or basically the investigation is telling us to mark any point. For example, this point as C. Doesn't matter what this point is or how much length it is on the perpendicular bisector, and that's what the question wants us to do. And then you have to join. I'm gonna use a pencil, my good trusty pencil, and I'm gonna join A to C. Okay, I'm going to join B to C as well. Okay, you can measure them now. This line is basically 4 point, how much? 4.8, I guess, or 7. 4.8 or 7 centimeter it is. And this line is also what? 4.8 or 7. That means these two lines are equal to one another. You can take any point as C. I can take this point as C, I can take this point as C, and I can join them with AB, and their length is always and always going to be equal. This side is going to be equal to this side. That means they're making an isosceles triangle in which two sides are equal to one another. Okay? That is exactly what the question is telling us. Then you can take point D anywhere, but not on the bisector. And like here, let's say this is point D. I can join A with D. Let me just do that properly. I made that point too thick. And B with D. Now obviously this side is not equal to this side. You can measure them, they will not be equal, and that proves what? That proves that any point on a perpendicular bisector of a line segment is equidistant from two end points of the line segment. What are the two end points? A and B are the two end points. Other than that, any point on the line segments means this C. Basically, any point you can have it. Okay? Equidistance, what does that mean? That means equal distance. It tells us that you can draw, basically means, it simply means that I can draw any point anywhere on the bisector, and the distance from that point to the end points, like this distance, okay, they're always going to be equal to one another. No matter how much they are or no matter how less they are, they're always going to be equal to one another. This is a simple piece of knowledge, or you can say it's a property of perpendicular bisector. Other than that, we have angle bisectors. We're going to learn how to bisect angles now. We learned how to bisect a line. Now we're going to learn how to bisect angles. Again, what is an angle bisector? Angle bisector is a line, ray, or a line segment that equally divides an angle into two equal parts. For example, I have 180 degrees angle. I divide it into two equal parts, 90 and 90. So if a line cuts 180 degrees into a 90 degree angles, and that means that is an angle bisector. If a line cuts 60 degrees into 30 pieces, and that means that is also an angle bisector. Okay? We're going to learn how to draw an angle bisector. I'm going to just make a random angle, okay? So one that is clear to see at least. Yeah, I don't know how much that is, but it's an angle. We have, let's say, let's call them A, B, C. Now I want to bisect this angle. Okay, I want to bisect BAC angle, whatever it is. Okay, I don't know what it is. I'm gonna bisect it though. I don't even need to know how much it is for me to bisect it. All I need is a compass. Okay, you're gonna place it on the vertex. Make sure that it's suitable. You have a suitable radius, a small suitable radius, 1 inch thick or like something like that. You're gonna cut it. You're gonna bisect both of the arms. Okay, no, sorry, not bisect. You're going to intersect. Means you need to cut them with an arc, with the same arc. Okay, both AB and AC, both arms, both lines of the angle needs to be properly intersected with a arc. Now I'm gonna name this point and this point. Let's say this is point L, let's say this is point M. Doesn't really matter, but the point is these two are going to be my center. This time I'm going to increase my compass radius a bit more. Let's say this much. It's comfortable, it's not too much, it's not too less. It doesn't really matter how much it is as long as it's a bit more. I'm gonna place my pointed end on L. Okay, I'm gonna point it and I'm gonna make an arc. I'm gonna make an arc here, a clear arc. Then from point M, I'm gonna make another arc. Okay, these two arcs are intersecting at this point. That's why your pencil needs to be sharp, so that you can pinpoint out the point of intersection. Right now my pencil isn't really that sharp, so it's not really pinpointing out the but I can't sharp this. If I sharp this, it'll get too small, and well, anyways, and if I sharp it, then you won't be able to see it, the diagrams that I'm making, because of the low quality of my camera. Anyways, yeah, this is the point of intersection between the two arcs. Let's call this point, let's call it D. Okay, again, naming is your choice. You can do it whatever you want. Then from point A to point D, this is basically the bisection. Now this angle and this angle is going to be exactly the half of what the original angle was. We can prove it now using a protractor. I'm gonna measure, let me measure this properly. Okay, well, this angle is approximately it's 60 degrees. It's almost 60 degrees, and the half of it is what? 30. Look, this is 60 and this is 30. The original angle was almost 60 and the half of it is what? 30. You could have taken any angle. Okay, it could have been 67 degrees or 68 degrees or 69 degrees or maybe 50 degrees or 54 degrees. It doesn't matter what angle it is. If you use this method, you will be able to bisect the angle. Okay, in this chapter we are going to do again and again similar kind of things, using compass to draw angles by making arcs in different ways, and you just have to memorize the pattern. Okay, memorize the method that I use to make angle bisectors, the method that I use to make perpendicular bisectors. You have to practice them over and over again and memorize them. There is nothing else in this chapter. You don't have to find the value of x, or you don't even have to use your brain. As long as you know the method, you will be able to draw it. Okay, let's read the question. The steps of construction for making an angle bisector. It says use a ruler and a protractor to draw an angle of 66, because the question is asking us to draw an angle of 66 degrees and then bisect it. Construct an angle bisector basically. So first we're going to draw the angle. I used a random angle because I just wanted to show the method, but maybe you'll have to draw a specific angle into the question. Here we have to. So first draw an angle then of 60 using a protractor. Simple. Okay, then with A as the center, and with a suitable fixed radius. Again, it doesn't tell you what the radius should be, okay? This is basically your choice, how much this radius should have been. Look, if I would have taken this too big, for example, let me just show you. If the radius I took was too big, like this, then I would have had to have a bit more than that here, like this. Wait a second. Like this, and the point of intersection is lying so far, and I would have had to go all the way there. Basically, it would have made my diagram too big, more than it needs to be. I could have done it in a smaller space, so just let's do it in a smaller space. Don't waste space. I could have done it by having a large radius as well, but that would have made things a little bit more uneasy. So have a bit small, good. Not too small like this. For example, if I have too small, it's hard to measure, it's hard to use the compass like this as well. And if I was to make arcs from that, it'll be too small and inaccurate. Okay, the more your radius is, the more accurate your measurements or constructions are going to be, but also it's going to take more space then. So if your radius is too small, then your measurements are not going to be that accurate. If it's too big, then it's going to take too much space. So you need to have a medium good size of radius, like this much, for you to be able to make a proper angle bisector. Or the same goes for all the other kind of angles that we need to make. If your suitable radius that you want to take is too much, then your angles are going to be accurate. Your construction is going to be more accurate, but it's going to take bigger space, more space. Okay, going back to the topic. With A as the center and with a suitable fixed radius, draw an arc to cut AB at P and Q. Here we have P and here we have Q. Okay, I completely did the thing. Okay, for example, he just only made small cuts here and here. I did a whole round off like this, completed the thing. It doesn't really matter actually. They can go ahead and complete it like this as well. It doesn't matter. The point is that you really need these intersections, okay? You need the intersections to happen. And then you're going to take them as your center and then make two more arcs, and that is how you make the angle bisector. While you're making this intersection and this intersection, your radius needs to remain the same. And while you're making the other two intersections from this point, your radius of the compass needs to remain the same. Okay, why am I saying the radius? Basically it's because a compass is mainly used to draw circles, and the distance from the edge, from the center to the edge, is what? A radius. So when I'm talking about how much you're supposed to open a radius or how less you're supposed to open the radius, I'm going to say how less you're supposed to open or more you're supposed to open a compass, I'm going to say the radius of the compass. Okay, just remember that. Basically the same thing the book does, what I did. Okay, go ahead and practice this over and over again. You will be able to do all kinds of bisection, and then you can use your, after you have done the bisection in the exam, you can use your protector to confirm that your bisector is you have properly bisected it. For example, we know 78 divided by 2 is equal to what? 7 3s are 6, goes up, we got, this should be the degrees of your dissection. Like one part will be 39 degrees and the other part will also be 39 degrees. You can confirm that after bisecting 78 degrees. Okay, then we have investigation, properties of an angle bisector. You can read it all. Basically I will tell you the summary of what it says. It says that a pretty much similar thing. Okay, I have this line of I have this bisecting line, right? I have this line which I am going to call an angle bisector because it is bisecting this angle, right? This line AD is my angle bisector, correct? I can take any point on this line, for example this point or this point, and I can make a straight perpendicular distance, okay, not from here, basically from here, from, okay, a perpendicular straight distance here and a straight distance from this line. This distance is going to be equal, okay, always. I can make another one here, a straight one. It needs to be perpendicular because perpendicular is the shortest distance, and again from here as well, because it is the shortest distance between these two lines, a perpendicular is, and that's why these two are going to be also again equal to one another. That's what this instruction, that's what this investigation is telling you, that any point on an angle bisector, any point on the angle bisector of an angle is equidistant from the two sides of the angle. Means this point or any point that you make on this angle bisector is going to have an equal distance from this line and this line, okay. That's just basically a simple thing that you need to remember. We're not going to basically use this as a rule, okay. This isn't a kind of rule that you need to remember in constructions, but this is basically just a property. For example, square have 4 sides. That's just a property of square, right? You don't really have to use it in constructions, you just have to remember that. This was basically it, and that's all that you need to remember in that, how to draw. Practice them over and over again until you have properly gotten the hang of it, okay. Next we're going to learn how to construct different angles using a compass. One method is using a protractor, okay. We can use a protractor to make angles, all these angles that I mentioned, and in this chapter we're going to learn how to use a compass to make all the angles. Basically in this chapter, the ones that are mentioned here, that's not going to be the only ones that we're going to discuss. There are going to be another few. I've written them down here. These are all the these are all the angles that you need to learn how to draw, okay. The most easiest one of them for now is basically 60, 120, 240 and 300. They are very easy. 90 is also very easy, and basically they're all interconnected. Most of them are interconnected with one another. So if you know how to make 60, you know how to make 120, you know how to make 240, you will know how to make 300. I'll show you how that works, okay. First of all, we're going to learn how to construct angles using a protractor. In case you have forgotten it, if you know it, then you can just skip this part of the video, okay. First of all, you have a straight line, correct. It has this end point, it has this end point, and this is, let's say, A, this is B. You're going to take this as your vertex, means you're going to have angle here on this side. Let me say I want to draw 54 degrees. What am I going to do? I'm going to place it here, okay. I want to draw, let's say I want to draw 54 on both A and B, okay. I'm going to show you how to draw it. First of all, I'm going to place my protractor exactly on top of A. The center of my protractor should be exactly on top of point A, okay, and the baseline of my protractor needs to be exactly in alignment with the line AB, okay. Then I am going to mark angle. Look, I have 54 on the inner scale and I have 54 in the outer scale as well. Which scale am I going to use? Since the base line AB is from the center towards which side? From center to, this is right side. So from the center to right side, we are going to use which scale? We're going to use inner scale. If it's towards right, then we're going to use inner scale. So this means I need to mark it off here. This is 50, this is 60, this is 50, and my angle is 54, so it's here. It's basically here. Okay, now I just need to make a straight line to that point. Right here. Yeah, that's it. This angle is what? 54 degrees. I want to make the same here. What am I going to do? Again, making sure that the center of my protractor is on point B. Then this time our baseline is towards what? it's towards left, so we're going to use the outer scale. In this case we have 50 here, 60 here, and 54 right here, and just we need to join the two together. This is now 54 degrees, both of them 54. That's how you basically use a protractor to draw angles. You can read the construction steps given here and clear your concept from that as well. Then we're going to learn how to construct angles using a pair of compass. We're going to start with 60 degrees because it is the most simple one that you can make. Okay, now I know this chapter is getting longer than this lecture is getting longer than I hoped it would have been, but your concepts are fresh right now, and with these fresh concepts we need to learn how to draw these angles, and you need to practice them now so that you can get a full grip on it. If we stop in between, then it's not gonna be good for us. So at least we need to learn how to draw these angles that are given in this chapter. Now we're gonna start with the easiest one, how to draw an angle measuring 60 degrees. I'm gonna be very plain, I'm gonna be very simple with you guys, okay? Making it as simple as I can. I have a straight line. Let's say this is line segment A and B. I want to draw a 60 degree angle from point A, or let's just say I'm going to make two 60 degree angles. I'm going to make a 60 degree angle on the line, let's say on M. I'm going to make a 60 degree angle on point M, and I'm going to make a 60 degree angle from point A, just to show you how it is on the end point and how it is in the middle of the line. We're going to start with the middle, okay? Take a suitable radius for the compass, okay? Pointed at on M, okay? Make sure it is suitable, okay, good. Then I'm gonna cut it completely like this, make a full semicircle, okay? It'll be better if you just even go like this much. I'm gonna show you why. Okay, that done. Now I'm not gonna mess with the length. I am not going to change the radius of the compass. The radius I had in the start of making these whole semicircle, okay, is gonna remain the same. I need to make sure that it remains the same, okay? Then with the same radius, I'm going to place, let's call this point, and let's call this point C, and let's call this point D. Okay, on point C, let's first place my compass on point C without changing the radius. Okay, radius is still the same. Look, it's still the same. Radius is still the same. I'm not going to change the radius. I'm going to place it on point C. Okay, the point of intersections, I'm going to place it there, and I'm going to cut the semicircle that I made. This, my friend, this right here is your 60 degree angle. That is it. There's nothing more complicated about that. You can now wait a second. This is, let's say, N. I'm going to join point M and N, and I'm going to continue onwards like a ray. Okay, so M and N joined and they continue onwards. It's a ray. Okay, this angle will be 60 degrees. That's how you make a 60 degree angle. It is just as simple as that. There's nothing complicated about it. I can measure it and I can show you. See, it's basically what my calculations and all. It's almost 60. Well, that's because my diagrams were not really that good, but it does make a 60 degree angle. Okay, that's how you make a 60 degree angle. First, take a suitable radius, draw a semicircle, or even if a full circle, it doesn't matter, and then on the point of intersection on the line AB, okay, on the line you have on the point of intersection, you're going to place your compass, and without changing the radius, you're going to cut the semicircle that you made. That intersection will be your new point, and when you join the 2 points with center and the new intersection point, basically that will give you a 60-degree angle. Now this is how you make a 60-degree angle. I'm going to show you how to make it here as well. Again, with a suitable radius, doesn't matter how much it is as long as it's not too much or too less. I'm gonna wait a second. I'm gonna continue again with let's just say this much. Doesn't matter, it can be complete circle as well, doesn't really matter. This is my point of intersection here. First point of intersection, I'm gonna call it, let's just say I. Point of intersection I. Now on with without changing the radius of the compass, I'm gonna place it on I, point I. Okay, and I'm gonna cut the circle that I drew. This new intersection, it's going to help us make the a 60-degree angle here. Again, it's gonna be, let's just call it P. Okay, so if I join A and P, I will have a 60-degree angle. Let me just join them. Yeah, that right there is a 60-degree angle from an end point. Doesn't really matter. I did this intersection, I named it as well. I'm going to tell you why later, but you can do it without any secondary intersection here. It just needs one intersection. Anyways, I'm not going to measure. I'm going to measure it. It's again almost 60. My diagrams are not really like okay. Then no, good. Look, it is 60 degrees. That's how you make a 60-degree angle. There is nothing more complicated about it. Okay. Now, how to make a 120-degree angles? That's the second most easy one to make without changing the radius. Again, first I made 60. Okay, first I made 60. First I made a semicircle or a complete circle. Okay, now without changing the radius, I'm going to place it on the point of intersection here. I'm gonna get, okay, what if I choose this as my point of intersection? Then I will have intersection here, right? And then I will have my 60-degree angle on this side of the line. Okay, first it was here, now it's going to be on this side. Yeah, then I'm going to be like this point, and this would be my 60-degree angle here. Okay, and that's why I made this. Okay, just to show you that if you want to make the angle on this side, you're going to use this and point of intersection, and if you want to make the angle on this side, you're going to use this point of intersection. How to make a 120-degree angle? That's the second most easiest one to deal with. Again, make a straight line A, B. Okay, I'm gonna make this point N. Here I'm going to make my 120-degree angle. It doesn't really matter whether it's the end point, whether you make the angle on the end point or whether you make it in the middle. It's basically the same thing. You're going to do the same things. Again, start with taking a suitable radius. Let's say this is 1 finger length. Well, one, is that a finger? No, okay. 1 inch length held. Okay. Making sure my pointed end is fixed on point N. Then again, yeah, you can complete the circle, you don't have to complete it, it doesn't matter. I'm not going to complete it this time, I'm going to just leave it like this. Now I'm going to take this intersection point, I'm going to call it D. Okay, now from point B, without changing the radius, I'm going to make an intersection on the semicircle that I made. It needs to be really perfect for the angle to be accurate. Okay, this intersection, I'm gonna call it point, I'm gonna call it let's say P. Now This is 60-degree angle. We already have done that before. This is 60-degree angle. But 120-degree angle is basically a continuation of 60-degree angle. I'm going to do the same now without changing the radius. Okay, make sure you're not changing the radius of the... Look, it's the same thing, same radius as it was before. I'm going to place it on point P, the new intersection, exactly on point P. And then I'm going to draw another arc that is cutting the semicircle that I drew. This point is now going to show me 120 degrees. Basically, this radius is 60 degrees. First time I did an intersection here. First I made an arc here on the semicircle, that was 60 degree. 60 plus 60 again is 120. Then if I add 60 again, let me show you. It is supposed to be 180, right? So if I add another 60 here, see, the next point of intersection is directly on the line. It shows that 60 plus 60 plus 60 is 180. So 60 degrees, 120 degrees and 180 degrees. You know how to make each and every one of them now. 60, 120 and 180. If you want to draw 60, continue only one arc. If you want to draw 120, you have to do one more arc. And if you want to draw 180 degree angle, then you will have to continue with that 3 arcs. Okay, our goal was to make 120, right? So this is our point of intersection that we're going to need. Let's call it M. So I'm going to join M and N. Okay, M and N, basically like this. Now if you measure this angle, this angle, it should be near to, or at least 120. Okay, I think it's right. Well, my angles are a bit off. Oh, now it's more near to 120. It's because I'm not doing really proper, but yeah, it's close to 120. See, it's close to 120. Since my base is on the right side and my angle is here, so I need to use the inner scale, and inner scale says it's nearly 120. So that's how you make a 120 degree angle. We have learned how to make 60 degree angle. We have learned how to make 120 degree angles when we know how to make 180 degree angles. Basically, if you continue here onwards, you're going to make a complete line, which is like a 180 degree angle. Okay, after this, let's just read what the book has to say, and then we're going to continue with onwards. Book says, draw a line segment BC with B as the center, okay, and with a suitable radius. Draw an arc that intersects BC at point P. Okay, you don't have to complete it just like I did here. I completed the circle. I didn't complete it here, but I completed it here. You don't have to. You just have to make an arc like this much. Doesn't really matter. Again, with P as the center, after that, with the same radius, the most important thing is here is that you're not going to change the radius. Okay, as you are making 60 degree angle, 180 degree angles and 120 degree angles, you are not going to mess with the radius that you have chosen. Okay, the suitable radius, it's your choice, but once you have chosen it, you're not going to change it. Okay, and then you're going to take P as your center, and with the same radius draw another arc, and then intersects that previous arc at Q, then join P and Q and join the extend B and Q to point A to form angle ABC. Basically the same thing as what I did, nothing new here. Then we're going to learn how to make 30 degrees. Now you tell me, is 30 the half of 60 or no? Yes, it is. And that means basically what we're going to do here is that we're going to bisect angle 60. First I made 60 degree angles, and then I'm going to bisect it. So I have a new line here. Let's call it A, B. I'm gonna make angle here. Let's call it C, point C. Okay, let's first make a 60 degree angle. My goal is not 60-degree angle, my goal is 30-degree angles, but I need to first make a 60 to make a 30. Okay, now of course I'm not going to make the line that shows it's 60, but the construction is going to be a little similar. Okay, firmly, let's make, yeah. Again, you don't need to complete it. As long as it's more than 60, it's fine. Then, without changing the radius, I'm going to, let me just call this intersection point D. At point D, I'm going to place the compass without changing the radius. Okay, I'm going to make an arc on the previous arc that I have made. Okay, this intersection is going to be named, let's call it point E. Now this is basically a 60-degree angle. We have a 60-degree angle. Let me just show it to you. Okay, this here is a 60-degree angle. That's not important for us. We need to bisect this angle to make 30-degree angle. Okay, you can, you can even make this as an imaginary line, just to be clear that this is a 60-degree angle and you're bisecting it. You can make an imaginary line. I made a real line, so it doesn't matter. Our goal is going to be 60. You need to properly show that it's, what do we do in angle bisection basically? We already have the point of intersections, this point and this point, we already have it. So what are we going to do? We're going to increase the length a bit, and then with the same radius I'm going to make two arcs, one from point E and one from point D. One from point E and one from point D. Now I have one more point of intersection, let's call it F, and if I join C with F, I will have my 30-degree angle that I need. That's basically say this should be near 30 degrees. Then I basically did the same thing, just one more step. I made a 60-degree angle and then I bisected it. How do you bisect? Basically the two intersections that you get in 60 degrees, for example here we got C and here we got N, right? Place your compass on C and N with the same radius. You're going to make two arcs, one from point C and one from point N, and you will have your bisection then. Okay, and that should be, let's measure it. Hopefully it's going to be close to 30 degrees. Yeah, see, it's near 30 degrees. So that's how you make a 30-degree angle. We know how to make a 30-degree angle now. This was the final time I'm going to show you and prove it to you that angles are equal. We're not going to waste our time measuring them again. Okay, I'm just going to show you how to draw angles. I showed you how to draw a 30, I showed you how to draw a 60, 180 and 120. Now I'm going to talk about how to draw a 90-degree angle. If you remember, we have already done this. Okay, you know how to make a bisectory line. You know how to do, we've done this before right here when we were doing perpendicular lines. We already learned how to make a 90-degree angle. If the line is perpendicular, then that means it's a 90-degree angle. So you don't have to do this again. It's the same thing. Okay, you know how to draw a 90-degree angle. You know how to draw it through a different method. Okay, they are using a different method, and they're using a bit of a annoying method, I think. You know how they basically here what we did was that we had point N. I'm not going to revise it, it's going to waste our time, but this method is also accurate. You can make a 90-degree angle from this method as well, but you can also make a 90-degree angle using this method. I'm going to show you how this method works. Okay, although it is a kind of waste of time, we already know how to make a 90-degree angle. Why should we learn it again? But this is a new method that the book tells us about, so we need to learn it. And this method is widely used most of the time. It is used in the geometry. Okay, so that's why we have to learn it. Let's call this point B. we're gonna go same. First of all, take a suitable radius. Okay, let me say this much. Let's say this much. Okay, firmly place it on point P. Make a semicircle. Okay, name this intersection point D. This is not really important, so we're gonna cut on that one. Let's gonna call this point, okay, let's call it O, point O, now that I've already ruined it. Okay, this point is O. From point O, then I'm going to make just like a 60-degree angle. Okay, I'm gonna make an intersection here, an arc that intersects the previous arc at point F. Okay, this is now a 60-degree angle. We're going to make 120 as well, so that means we need to continue one more time here. This point, if I go from here, this will be 120 degrees, and let's call this point E. Now that I have my 60 degrees and 120 degrees, what comes in between 60 and 120? Okay, the middle number in between 160 and 120 and 60. The middle number in between 120 and 60 is 90. Okay, so that means if you bisect this, or simple as that, just forget about bisecting. Okay, I'm gonna open it to a suitable length. I'm gonna place, okay, I can change the length now. Okay, first of all, I couldn't change it, now I can change it. I'm gonna open it a bit more so that I can be more accurate. Okay, I'm gonna place my pointed end on E, and I'm gonna mark an arc here above AB. Okay, then from point F, without changing the radius, I'm going to make another arc. Okay, that intersects our previous arc, and this point, basically this point of intersection, let's call it G. When you join this G with P, you will have your 90-degree angle. Done. Okay, that's how you make a 90-degree angle according to your book. We've already done this another method before, but you can also learn this method. You should also learn this method. First make a 60 and 120, and then basically bisect them. Okay, in one way you're doing a bisection, but you can say place your compass on 60 and then 120 and then make 2 arcs. You'll be able to make a 90-degree angle. Okay, we've learned how to make a 90-degree angle now. Okay, so we can cut that out. We've learned how to make 30, 60, 120, 180. Now I'm going to show you how to make 45. Okay, now I hope this already rings a bell, because 90 and half of it is 45. So after making a 90-degree angle, we can just bisect it and we will get what? A 45-degree angle. So you have two ways of making 90-degree angle, right? First of all, you made a 90-degree angle. I'm going to use the same example. First you made a 90-degree angle. For you to make 45-degree angle, you first need to make a 90. Okay, once you have made the 90, then this will be your point of intersection. Okay, this is point O and this is point let's say R. From point O and R, I'm going to bisect it. That's it. Okay, first after making a 90-degree angle, by this method or by the other method, you make a 90-degree angle, or then you can, then on the semicircle you have, okay, if you don't have it, you're going to make it, right? So on the semicircle, you're going to, where the 90-degree line, this line, where this line intersects with the semicircle, you're going to make point R, and then from point R you're going to take a suitable length, a suitable radius. Okay, it doesn't really matter how much it is. The thing is, you're not going to change it once you have selected it. I'm not going to change it. This is what I've selected. From point R, basically all that you need to do is to bisect 90-degree angle. I changed it. Putting too much force will also ruin your diagrams. Okay, look at this. My first line was this much, and then the second one was a bit further than that because I put too much force. Okay, so you need to be gentle and precise. No, I need to remove it. Okay, once again, let's try. From point R, I've taken a suitable radius, and I'm gonna make an arc gently. Make an arc that is clear to see. Okay. Then from point O, which is another intersection, I'm going to make another arc. Now I have cutting the previous arc, right? So I have two arcs intersecting at this point, which is going to be, let's say, point T. Now I'm going to join P with T. Okay, this will give me 45 degrees. I first made a 90-degree angle, and now I bisected it. Okay, this should be 45 degrees. Okay, that's how you make a 45-degree angle. You first make a 90. Now you know that where the 90 is, and you're going to make a 45 by bisecting it, just like how we did with 30 for 30-degree angles. First we made a 60 and then bisected it. Practice your bisections. Okay, after knowing how to make a 45, we're going to learn how to make 240 and 300. Don't worry, they're very simple and very easy, as long as you remember what we did in 60. Okay, I'm going to repeat that here, and let's say I'm going to make my angles on this point. Let's call this point G. First of all, take a suitable radius. Let's call it this much. Okay, fine. Firmly at point G, then make angles. Okay, that does it. Oh no, that doesn't does it. We need to have a complete circle this time, because we're making a reflex angle. Not a complete circle, but it needs to be at least half complete, or like something. Yeah, this much is fine. Now I'm going to call this point of intersection F. Okay, I'm just making a 60-degree angle. Okay, just like always, we're not going to mess with the radius. Again, do not mess with the radius of the compass. Keep it same. I made a 60-degree angle. This point of intersection is going to be E. Okay. Oh, what is this? It looks like an S, so let's just say it's an S. I wanted to make a G though. It's an S. Anyways, this is a 60-degree angle. We need to continue. 60 plus 60 is 120, and that we have a 120-degree angle now. Making sure, I'm just going to check if my radius was messed up or not. Wait a second. No, it's fine. My radius is fine. I haven't changed the radius. So from point E, I'm going to make another arc here, and this point is going to give me my 120 degrees. Let's call this point D. Okay, if I continue from 120 plus 60 is 120 plus 60 is 180. That's what I have here. At this point, 180 degree is complete. After 180 plus 60 again. Okay, so I'm gonna continue from this point. I'm gonna continue from this point. This again. Constructions can be annoying, but they're easy. They're not that difficult. Okay, then if this is 180 plus 60 is going to be 240. Then that is how you draw a 240-degree angles. Okay, 60, 120, 120, 180, and then this is 240. Let's call this point Let's call this point C. Let's call point this B. And again, just guess what? If this was 60, this is 120, this is 180, this is 240, then the next one is going to be 300. Okay, if I continue on from this, I will get, if I continue on, I will get, let's say this is point A, I will get 300. And if I continue from 300, I will get what? 360. A complete circle. 360. 300, then 360. That's how you basically draw these angles. If you want to draw 16, then you're just going to use this line. You're going to make a line like this. If you want to make 120, make a line like this. If you want 180, that's 180. If you want 240, then I'm going to continue like this. If I want a whole 300, then I'm going to continue like this. One more way of making 300 is just making a 60, okay, just making a 60 degree and taking the reflex. If you make a 60 degree angle and just take the reflex, that is going to be 300. Okay, so that's how you make 300 as well. We know how to make 240 and 300 as well, and 45 degree as well. We now need to learn how to make these other few angles that are left. Again, how do you make 270? 270 is exactly 90. Okay, it's the exact same way as making 90 degree angle. If this is 90 degrees, if this is 90, then the rest of it is going to be what? 270. So if you make a 90 and take the reflex, that's basically your 270. So there is no difference here. Okay, we don't need to learn how to draw it. It's just draw a 90 and take the reflex. That's going to be 270. Okay, now that we know how to draw, okay, we're going to learn how to draw 15 next. 15 is easy. Or you can learn how to draw 75 as well. Basically, if you look, how did we make 90? We basically took the middle number of 60 and 120. The middle number in between 120 and 60 is 90. So when we were making the 90 degree angle, what did we do? We put our compass on 120 and we put our compass on 60, and we make arcs, joining arcs, right? And that gives us 90. The same is going to happen for us when we are making 75. First we're going to make 90 and then we're going to make 60. So no, first we make 60 and then we make 90, and we're going to find the middle number in them, which is 75. So basically you're going to put your compass on 90 and then on 60 and make arcs, and then by this, basically you're bisecting here some in one way, and that will give us 75 degrees angle. Okay, so we're going to learn how to draw these in accordance to your book. We know how to draw 45, we know how to draw 120, then we're going to learn how to draw 75. Okay, the question, okay, now we're going to deal with 75 degree angle, right? The book does it in a different method, and I'm going to show you one more method of drawing 75 degrees. Okay, first I'm going to show you my method, and then I'm going to show you what the book does. The reason why is because book also, while dealing with 75 degrees, you're also going to learn how to make 150 degrees. So before that, I want to show you how to make 75 without even knowing how to make 150 degrees. Okay, I have a line here. Let's call this point A. I'm going to make I took a suitable radius. Okay, I'm going to place it on A. I'm going to complete a semicircle. Okay, I have my semicircle. I'm going to mark 60 degree angle. How do I do that? First, marking this point of intersection as B. Then from B, I will make an arc on the previous semicircle that I have drawn. From point B, I have made an arc here. This is going to be our 60 degrees. Okay, let's call this point C. Okay, this is 60. Now we're going to make 120. This is 120. Okay, what is in between 120 and 60? Yes, 90. 90 is in between 120 and 60, so we're going to make 90. You already should know how to make 90, right? So basically you can change the length now, but you don't have to, so let's just keep the same radius. It doesn't really harm us anyway, so keep the same radius, and we're gonna make 90-degree angle. Basically, if I'm gonna make an imaginary line here at this point, well, I have it here. This is 90, right? So 90 comes in this point. 90 degrees will come here on the semicircle, right? Let's call this point C. We called it D. Then I'm gonna call this E. Point E. Okay. Same method. Everything that we did before, right? Up until now, I used the same method that we used to make a 90-degree angle. Now, the number that comes in between 90 and 60 is 75. So basically what I'm going to do is that I'm going to place my compass on 90, make an arc, then I'm going to go on 60 and make an arc that cuts the previous one. What the hell? Wait a second, this is not really nice. Oh god, I really need to be more neat. Anyways, this point basically here should be our 75 degrees angle. This intersection should be, I'm not sure, let's see. This is point F, should be point F, right? Yeah, okay. I'm gonna join A with F. Yeah, and let's see, where is it? Here we go. I'm not sure, that's why we're checking here. God. Yeah, so this is pretty much, yeah, 75. It is near to 75. This is 75, and our one is near to it. If my angle is a bit off, so yeah, my line is a bit off. This angle was supposed to be 75. That is how you make 75. First make 60, then make 120, then make a 90, and you can put your compass on the 90-degree angle and then the 60, making two arcs, and when you take the intersection, join it from point A. That's basically your 75-degree angle. Okay, that's one method of making a 75-degree angle. Another method that is mentioned in your book is basically first making a 150-degree angle. How are you going to make that? Let me show you how to make a 150-degree angle. First making a 150-degree angle and then bisecting it, because half of 120 is 75. This is two lines basically. Let me just make this a thick line. Okay, we're going to draw this again. A line, let's call this AB. I'm going to make an angle on point C here. Okay, now from point C, take your compass with a suitable radius, make a 60-degree basically, and then 120. Okay, just like usual. I told you 60 and 120, they're really important. Most of the angles depend upon them. Okay, and then I have my first intersection. Let's call this point D. From point D, I'm going to make a 60, This is now going to be my point E. Then we're gonna make 120. Okay, this is 120. We made 60 degree, we made 120, and now we know this is what? This is 180, right? So 180 and 120. The number that comes in between 180 and 120 is basically what? 150. So we're going to place our, you don't have to change the length, but you can if you want to right now. I'm not going to change it, so let's just not change it. Let's not complicate things. I make an arc by placing the compass on this intersection. Let's call this intersection G. Okay, made an arc. Then again from point F I'm going to make another arc here. This is going to be our point P, and when I join C with P, that's basically my 150 degrees. Okay, this is 150 degrees. That's how you make 150 degrees. You know how to make 150 degrees. Now we're going to learn how to make 75 from that. Basically this point of intersection and this point, taking the semicircle wherever it touches these two arms of this angle. Since this is our what? 150. We're going to learn how to bisect 150, and that bisection is going to be equal to 75. Okay, now I'm going to change the length so I can be more accurate. Place it on this intersection, making an arc here, then at point D making an arc here. That is going to be basically this is going to be the 75 degree angle. Let's call it point Z. Okay, now I'm going to join C with Z. That should give me my 75 degree angle. Now I'm sure my calculations are not really pretty because I was rough, but look, that is equal to, that is in between 70 and 80. That's my 75 degree angle. Okay, that's how you make a 75 degree angle. I told you how to make 75 and 150 as well. Okay, you know how to make 75, you know how to make 150. The ones that are left are 105 and 15 and all of these. Okay, fine, let's learn how to make 15. We already know how to make a 60, and the bisection of 60 is what? 30. And if you bisect that one, you will get 15. If you bisect 30 degree angle, you will get 60, right? Yes. If you bisect 30, you will get 15. Jeez, what is wrong with me? We have this, let's call this point B. I'm going to make a 60 degree, then I'm going to make 30, and then I'm going to make 15. That's how you make 15 degrees. Okay, a semicircle with a suitable radius. Then from this point, which we're gonna call it point A, I'm gonna make a 60 degree mark here, cutting off the previous arc. This is now point C. This will give a 60 degree angle. So now we're going to bisect that 60 degree angle. I can show you. Let's be more practical here. I'm just going to make an imaginary line that shows that this is the 60 degree one. Then we can change the length now so that we can be more accurate. From this point of intersection and from A, we're going to make an arc. This is basically 30 degrees, right? We bisected the 60 and we got 30. So this is our 30 degree angle. Now this point of intersection and A, we're going to call this point Z. So from point Z and ZA, we're going to make another bisection, and that will give us what we need. from point Z and point A. And that's why your pencil needs to be sharp, because you won't be able to see the intersections properly if your pencil isn't sharp. My pencil isn't, so that's why it's hard to see the intersections here. Anyways, this is the intersection here, and let's just call this point P. So if I join B with P, I will be making a 15 degrees angle. Should be a 15, at least around that. We can check it. This angle is, look, between 20 and 10. It's between 20 and 10, that's 15. So we were able to make 15. First make 60, then make 30 by bisecting it, and then bisect that 30 as well. You will get 15 degrees angle. Our next is going to be basically 105. Why 105? Because you know how to draw 75. Take a look at this one. We've done 75 degrees, right? What did we do in that one? We made a 60, then we made a 120. In between 120 and 160, 60 and 120, we had 90. And in between 90 and 60, we had 75. So what if instead of taking this side, I take this side? For example, what is going to be in between 90 and 120? That answer is 105. That means the method of making 75, the method that I showed you, is very similar to making the method of making 75 that I showed you is very similar to the method of making 105. Okay, I'm gonna show you once again. Let's call this point A. First make a 60 with a suitable radius. Okay, this point of intersection, well, let's call it, okay, from this point of intersection, I'm gonna name them in the end. This is okay. I changed the radius. See what happened? I changed the radius. My calculation was going to be wrong. If you happen to change the radius, just go back to the previous step and measure it again. Look, I measured it again. Now my radius is back to what it originally was. So now I can continue with my calculations, construction. This is a 60. Placing it on 60. I will get 120. Now placing it on 120 and 60, I will get my 90. Okay, where's my pencil? Yeah, okay. 90 is right here basically. I'm gonna make an imaginary line here to show the 90-degree angle, and 90 intersects here, right here. Okay, 90 intersects the semicircle right here. So I'm gonna place it on, wait a second, let me call this point P and let me call this point G. The rest of the points I'm not gonna name them, it's just a waste of time right now. Oh, I changed the length again. I'm gonna change the length, so measuring the length back. Okay, fine. Now from point G, which was 90, and P, which was 120, we're going to do an intersection. Oh, it doesn't intersect. Wait a second. Okay, God. Yeah. Now we have the intersection here. Basically, this is going to be our, if it was on this side, then it would have been 75 degrees. If it's on this side, now I can say this is what? This is 105 degrees. This angle is basically what? 105. The method is pretty much very similar to how we made 75 degrees, but there we took 90 and 60. We made arcs from 90 and 60 degrees. Here we're making arcs from 90 and 120. and in between them we have 105 degrees. Okay, that's how you make 105. Okay, now we're going to learn how to make other angles. Now we're going to learn how to make 225 degree angle and 135 degree angle. They are not really that hard actually. We have 45 degrees. If you know how to make 45, then you know how to make these two. They are very simple and they're very similar. How do we make a 45 degrees angle? First we make a 90, okay, and then bisect that 90 degree angle. Okay, so first we make a 60, then we make 120, then through that we make a 90 degree angle and then bisect it, so we will get 45. Once you have a 45, okay, let me ask you two things. There are two questions that I want to ask you. Okay, if I have 180 and I minus 45 from it, what do I get? 180 minus 45, what do I get? I will get 135. That means in a straight line I have two angles. One is 45 degrees, the other one is going to be what? The sum of them is going to be equal to what? Sum of them is 180. So 180 minus 45 is what? 135. So if you know how to draw a 45 degree angle, the other one is going to be 135. So just draw a 45 degree angle and take the other one as your angle. Okay, draw 45 and take the other part of it as your angle, required angle, and that's going to be 135. That's how you draw a 135 degree angle. You just need to know how to make a 45 degree angle. Other than that, let's know how to make a 225. This is also very easy. This is a straight line. A straight line has how much? 180 degrees, correct? 180 plus 45. What is that equal to? 180 plus 45 is 225. That means if I make a 180, that's a straight line, and if I make a 45 degree angle here, if I just take my I flip my diagram upside down and I make a 45 here, what will I have? I have 180 plus 45. And what is 180 plus 45? It's 225. So if you want to make 225 degrees angle, you need to know how to make a 45 degree angle. You can basically just make a 45 normally, just like you do, okay, and take this as your angle. This complete will be what? 225. Only this is what? 45, and complete this is 225. So if you know how to make 45, you know how to make 225, and you will know how to make 135. I'm gonna do them one more time here. I'm gonna show you how to make 45, and as well I will show you how to make these other two angles that we just discussed. Okay, let's say this is point A. We're going to take our suitable radius here. Okay, then I'm gonna, this point is, this is, let's say, B, point of intersection. Oh, I changed the length again, my mistake. Oh, I didn't. I thought I messed with the radius. I didn't. Okay, good. Again. Okay. This is going to be 60 degrees. Let's call this point C. Then from point C, I'll make another arc. Okay. This is going to be point D. Then in between 60 and 120 I will have 90. Okay, this point here, let's call it E. I'm going to join A and E to show this is imaginary line. Okay, this is 90, this is 90, this is 60, this is 120. So what am I going to do? I'm going to place my, I need to make a 45, so I'm going to place it here. I can extend it Okay, just so that I can have more accurate measurements, I make an arc from 90 and then from point B. Let me be more clear here. Yeah, this point is going to be what? 45 degrees. That's how you make a 45-degree angle, right? Now let me show you. If this is 45, if this side is 45, then what is this going to be? This is going to be 135. Okay, that's how you make a 135-degree angle. And if this is 45, then this hole is going to be what? 225 degrees. That's how you make these two angles. This is what? 45. They're all connected to one another. So we've learned how to make all the angles that we needed to know for now. Okay, that's it in this exercise. We're going to do this in class. 11.4 reflection, we're going to do this in class. For now, I'm going to have to ask you to make a few things. In exercise 11A, this is your homework, to draw A, and you can also do this one, and you can also do this and this. So these 4 questions will be your homework. I've showed you all how to do them. Okay, I've showed you how to make 60. You do that in your notebook. I've showed you how to do 45, 105, 90, 75, 120, all of them. I showed you how to do them. You will go ahead and do them by yourself in the notebook. And basically this is bisecting, which is very easy. You just have to bisect these angles. And this is also perpendicular bisectors and angle bisectors. It's also very easy. And you don't even have to draw these angles using a compass, just a protractor. So it shouldn't be that hard. That's it for now.